Humans have walked on the moon. They can live in space for months. They have sent machines beyond the edge of the solar system. And yet, the deepest parts of Earth's oceans remain unseen. There are places on this planet where no human has ever looked directly. No camera has stayed long. No signal has returned intact. We map distant galaxies in detail, but large sections of the ocean floor are still guesses, shadows, and gaps. So how is it possible that leaving Earth is easier than exploring it? What does the ocean do that space does not? Its surface is familiar. We sail it, swim in it, and cross it with cables and ships. From above, satellites photograph the sea as a smooth, moving skin. But that image lies. The ocean is not flat. It is a layered world, stacked with pressure, darkness, and distance. Space begins at the edge of the atmosphere, and once you are there, conditions barely change. There is no weather, no friction, no crushing force pushing inward. A spacecraft floats in a near-perfect vacuum, and as long as its systems hold, the environment stays calm. The ocean does the opposite. Pressure starts at the surface and increases relentlessly. Every 10 meters down, the weight of another atmosphere presses in. At 1,000 meters, the pressure is more than 100 times what your body feels on land. Steel bends, glass shatters. Even specialized deep-sea submersibles must hide their occupants inside thick metal spheres no bigger than a small car. This is why the ocean is harder to explore than space. Space tries to kill you quickly. The ocean kills you slowly, silently, and without warning. A tiny crack in a hull does not explode outward. It collapses inward, crushing everything in an instant. And the deeper you go, the worse it gets. At depths beyond 3,000 meters, where sunlight has never reached, pressure is strong enough to deform solid metal over time. Engineers cannot simply build thicker walls. Weight becomes the enemy. Every extra centimeter of steel adds mass, and mass makes descent harder and failure more likely. Unlike rockets, which can be reused again and again, deep-sea vehicles age with every dive. Microfractures form invisibly in the hull. Seals weaken. Materials that survived one descent may fail on the next. This is why most deep-sea missions are rare, brief, and cautious. The ocean does not forgive repetition. Then there is the problem of seeing. In space, light travels freely. Cameras can look outward for millions of kilometers. In the ocean, light vanishes within the first few hundred meters. Beyond that, cameras see nothing unless they bring their own light, and that light only reveals a narrow tunnel of floating particles and falling snow. Radio waves, which carry voices and data through space, die almost instantly in seawater. To communicate, explorers must use sound. Sonar pulses spread outward, bounce back and return as distorted echoes. The deeper the water, the less reliable those echoes become. Sound bends, scatters, and lies about distance and size. This is why we have clearer maps of Mars than of Earth's own seafloor. Vast regions of the deep ocean are still drawn from low-resolution sonar sweeps, filled in with educated guesses. Mountains may be taller than skyscrapers, trenches deeper than any canyon on land, and no camera has ever shown them clearly. And this is still the easy part. The pressure so far is survivable. The machines still respond. The signals still come back. The true deep lies below, where the ocean stops behaving like a place at all. Down there begins the part we cannot control. The true deep begins where pressure is no longer just a number, but a constant force pressing from every direction. At 4,000 meters, the ocean enters the abyssal zone. The water here is near freezing, barely above 0 degrees Celsius. There is no sunlight, no seasons, and no reference point for distance or direction. A submersible descending into this space does not feel like it is traveling downward. It feels like it is being wallowed. At these depths, pressure exceeds 400 atmospheres. That is the weight of several fully loaded freight trains pressing down on every square meter. The strongest deep-sea vehicles ever built, like titanium-hulled submersibles, must be shaped like spheres to survive. Flat surfaces fail. Corners fail. Even tiny imperfections become fatal. Cameras show hulls groaning and flexing as they descend, metal responding like something almost alive. Human presence down here is brief and rare. Most exploration is done by unmanned vehicles, tethered to ships by long cables that twist and strain under their own weight. These cables carry power, data, and control signals. If one snaps, the vehicle does not drift upward. It sinks, slowly and silently, until it reaches the seafloor and becomes another object lost to the dark. The seafloor itself is not empty. Video footage reveals landscapes that look more alien than anything in space. Vast plains of mud stretch into blackness. Jagged mountain ridges rise higher than the Alps. Deep trenches cut into Earth's crust, some nearly 11 kilometers deep. In places like the Mariana Trench, pressure is so extreme that even simple mechanical movement becomes difficult. Life still exists here, but it follows different rules. Fish have soft, flexible bodies with no air-filled spaces to crush. Their bones are thin. Their muscles are slow. Many animals are translucent, their organs faintly visible, glowing with soft bioluminescent light. Some creatures grow to enormous sizes, while others barely move at all, conserving energy in a world where food drifts down slowly like falling dust. Every deep-sea dive reveals new species. Cameras often capture animals never seen before, their shapes unfamiliar and unsettling. Even now, scientists estimate that most deep ocean species remain undiscovered. The ocean does not just hide them, it actively resists our attempts to find them. Exploration here is not only a technical challenge, but a psychological one. Piloted submersibles trap their occupants inside spaces barely large enough to sit upright. Thick walls block all sound from the outside world. There are no windows, only screens fed by cameras that show a narrow cone of illuminated water. Hours pass with nothing visible except drifting particles and the occasional sudden movement at the edge of the light. In space, astronauts can see Earth below them. They can look outward, orient themselves, and understand where they are. In the deep ocean, there is no horizon, no sky, no sense of scale. Up and down lose meaning. Time stretches. The environment feels less like a place and more like a condition. This is why the ocean remains Earth's last great unknown. Space allows observation. The ocean demands endurance. Space lets us orbit, return, and try again. The ocean limits every attempt to a single, careful descent. Each dive risks permanent loss. Each failure disappears without trace. We have explored other worlds before we have explored our own. Beneath the waves lies a vast, living system that shapes the planet, drives climate, and feeds the surface world, yet remains largely unseen. And somewhere down there, in the pressure and darkness, animals have adapted in ways that make even our strongest machines seem fragile. If this makes you want to look deeper, stay with us. If the ocean feels a little more unsettling now, please like and subscribe, then continue into the darkness with the video on why sperm whales get deadlier the deeper you go.